Good morning, unless of course you're in periods 8, 9, or 11, because then it's good afternoon. I know you're probably looking forward to an easy day today, but lucky for you, I've discovered technology. So this way, I can still be here with you, even when I'm not here with you. Alright, today we're going to discuss deposition. You'll have some time to start your homework after we're finished here, so let's get going. Deposition is the geologic process by which sediments in soil and rocks are added to or dropped on a landform. We've talked about this. You know what this is. Erosion picks the stuff up and carries it somewhere, but then eventually it has to get dropped off. When it gets dropped off, that's called deposition. All right? Deposition occurs, you know, in a stream when the water slows down. It also occurs when the wind slows down. It occurs in a glacier when the ice melts. The glacier is basically like a big dump truck. It's carrying the sediment with it. It's only going to drop it when it actually goes away. All right, it can start and stop, but it isn't going to let anything go until the ice melts and then turns into water. Okay. Sometimes deposition is also referred to as sedimentation, since layers of sediment will build up on the ground. All right. Factors that affect deposition. All right, these are sometimes described as characteristics, what the sediment particles are like. All right, the first factor we're going to talk about is particle size. When you're doing an experiment or when you're discussing particle size, how it affects sediment, you have to make sure that all of the particles are the same shape and the same density. Because if you don't make sure they're the same shape and density, then you don't know why the particle is settling out in the pattern that it will deposit in. Okay, so let's look at some information from an experiment. Particles were used in this activity. These are all off the Earth Science Regents exams. You can see here on the left side you have a particle that is 15 millimeters in diameter. It's aluminum. Then you have a 10 millimeter aluminum sphere, and you have a 5 millimeter aluminum sphere. They all are aluminum, so they all have the same number of molecules in the same amount of space, so they all have the same density. Over on the right-hand side, you can see over here the density of the particle of iron, same size as the 15 millimeter particle of aluminum, but its density is higher, 7.9. And then the 15 millimeter lead sphere, same size as the iron and the aluminum, the 15 millimeters, but it has a density of 11.4 grams per cubic centimeter. So, which pattern, or what pattern, will different sized particles settle out in the water? All right, so stop and think about this. Remember, you can't figure out the answer unless you stop and think. If I drop a whole bunch of stuff that are all different sizes, but they're all made of the same stuff, which particles will end up on the bottom? Which particles will end up in the middle? Which ones will end up on top? Did you say number 3? Because if you did, you were right. The largest particles will settle first, or they'll settle the fastest, and then the smallest particles will settle last, or they'll settle the slowest. Okay, why is that? Well, because the bigger ones have more mass, they're all the same density, so their weight isn't going to change. Well, I take that back. Their weight will change because of the different sizes, and that's what will cause them to settle in that order. All right. Clay particles. I need to mention here that clay particles will stay suspended in water for a very long time. They're so tiny that even the slightest movement in the water will keep those little particles suspended. Second factor is particle density. All right. You need to make sure they all have the same size, they all have the same shape, and we're going to go back to our data, and now we're going to use the 15 millimeter aluminum, the 15 millimeter iron, and the 15 millimeter lead particles. Which pattern will particles with different density settle out? So if I take aluminum, iron, and lead spheres, put them in a beaker, drop them in water, who's going to settle the bottom first, fastest? Who's going to settle in the middle? Who's going to settle on top? Stop and think about it. Did you say number 3? Because if you did, you're right. The most dense particles will settle first, they'll settle fastest. The least dense particles will settle last, or they'll settle the slowest. They're the ones that'll be on top. Try not to use, or try not to think of it in terms of weight or in terms of how heavy they are. It's the density, how many molecules there are in how many square centimeters. All right, let's move along here. Particle shape is the third factor. Here we have round, oval, and flat shapes. All of the particles must be the same size. They must all be the same density. So that way you know that the only thing affecting how fast they settle is the shape. So it all has to do with how fast the water can move around the particle. So let's look at the round particle. There goes the water. The water came up and it moves around the water. The water moves around the particle fairly easily. If you look at the oval, is it going to take longer, take more time, or is it going to take shorter or less time for the water to go around the oval? Well, since it's wider, it's going to take longer for it to go around there, so it'll take a little bit more time for the water to move around there. And then if you look over at the flat particle, this is the flattest, so it takes up the most area, so it's going to be the longest time for the water to flow around it. So based on particle shape, the round particles will settle the first or the fastest because they're pretty much aerodynamically designed, only in this case with water flow. And the flat particles will take the longest, or they'll take the slowest amount of time to settle to the bottom. Here we have an old Regents question. It says which particle size, which table shows the correct settling times based on particle shape. So take a second and look at this. You should know that you can eliminate number 2. Why? If you said because they're all the same, you're correct. Can't be all the same. They're all different. If you look at those, which one is going to settle to the bottom fastest? The round one is. Is that going to take more time or less time? It's going to take less time. The flat one takes the most time, so that's number 3 again. Quiet water. If we have water sitting there, like say a lake, all right, maybe a landslide occurs and all that sediment falls into the water. The water is quiet. It's just sitting there. What's going to happen? You're going to have something called vertical sorting occur. In vertical sorting, the particles are going to settle out. How are they going to settle out? What are they based on? How big they are, how round they are, and how dense they are. Who's going to be on the bottom? Stop and think. Did you say the biggest, roundest, densest particles? Because if you did, you're right. Which ones are going to be on top? The smallest, flattest, least dense particles will settle out on top. This is also called graded bedding. It's graded because it's arranged in order from largest, most dense, most round, up to the smallest, flattest, least dense one. All right? Think of tests. When I grade tests, what happens? Well, I'm going to end up with a whole bunch of tests that are going to be in order from smallest to largest. Here's what it looks like in nature. So here's a gentleman who's walking along, was probably an old lake bed, and you can see here that down on the bottom you see these larger particles, and then it starts to get smaller, and then it gets larger again, and then it gets smaller. And it's kind of hard to see. It's not a nice, neat diagram, so it's a little bit tougher to see the vertical sorting, but it's there. Moving water. Okay, if the water is moving now, say in a stream or a river, it's going to be moving horizontally, right to left, left to right, north to south, east to west, downhill. The particles are going to settle out in a different pattern. You're going to see what's called horizontal sorting. When you have horizontal sorting, as the elevation drops, as you go from high up on the mountain down to lower elevation, it's going to slow down. The stream will slow down. It has the most speed up high. It has the least speed down on the plain, so it's going to drop particles off exactly the way it shows you on page 6 on the graph in your reference tables, top right corner of page 6. The boulders will be up here, then the cobbles, and then the sand, and then the silt and the clay out here on the far right. The big round dense particles, those are the boulders. The small flat least dense particles, those are the clay particles. This occurs, like I said, in streams. Which pattern will particles settle as a stream enters a lake? Okay, this is one that most folks understand the question, but they usually choose the wrong answer. You know it's going to be big to small. Which one is it? Most folks historically, they end up picking number 4. That's wrong. It's in the wrong order. Which one is it? If you said number 3, you're right. Okay, here's another one, another diagram, and it shows you the same thing. The only difference here is this goes way out into the deep water over here into the ocean, and you'll notice that there's a brick pattern there. What rock is that? That's limestone. Limestone will form out there in deep ocean water. A river delta. A delta forms at the end of a river. Everyone knows that. It's a big pile of dirt. It's a big pile of dirt that forms underwater. It's a triangular shaped pile of sediments that forms at the end or at the mouth of a stream. Here's what happens. Over here, the stream enters the ocean. The ocean is water that's not moving. Think of the water slide that we talked about last week. When it hits that, the stream slows way down and it starts to drop particles. What's it going to drop first? 3 things: the biggest, the roundest, and the most dense. And what's going to happen is a big pile of dirt is going to settle out here and form and create what we call a delta. Here's an example. Here's the Mississippi River Delta. It's called a bird's foot delta. The main channel comes down through here, and then you have actually little mini deltas. They're called lobes. Those lobes form where you have what are called distributaries. Distributaries take water away from the main stream. Tributaries contribute water. Distributaries take water away. So where the streams form upstream, all of those streams come together. The small streams come together. They contribute water to the main channel. And then at the end of this river, right before it empties into a lake or the ocean, it takes the water, they take water away and distribute it out to the ocean. Here's the Nile River, same sort of thing. And where are the distributaries? Well, there they are. Those are 2 of them. There are smaller ones, but on this frame, this is what you can see in this image. And the last thing we need to talk about is an alluvial fan. An alluvial fan and a delta are the same thing. The only difference is location. It's like magma and lava. Magma is underground, lava is at the Earth's surface. All right? An alluvial fan is a delta. A delta is underwater, and an alluvial fan is on land. It's a delta found on land, usually in flat areas. So here we go. Here is our mountain chain. Out here it's nice and flat, and there's your delta. The streams tend to be very small. They come out of the hills, usually at high speeds because they have high elevation. They're carrying a lot of sediments, and then when they hit that flat plane, they slow way down, and then they drop all of their sediments in a great big pile. And here's another picture, different area. You can see there's an alluvial fan here. There it is right there, big triangular shaped pile. And then there are 2 other ones here. How's that? Alright, so we learned about deposition today. We went over a lot of stuff pretty fast. Okay, it's when stuff gets dropped. Once it gets dropped, it's going to be dropped in patterns. It's going to drop the big, dense, round ones first, the small, flat, least dense ones last. If it's quiet water, you're going to get vertical sorting, big, round, dense on the bottom, small, flat, least dense on top. And then if it's moving sideways, you're going to get horizontal sorting, boulders, cobbles, pebbles, sand, silt, and clay. And then you have a delta, and you have alluvial fans. Big piles of dirt, the delta's at the end of a river, underwater, and alluvial fans at the end of the river, on land, usually where mountains go into the plains. Well, thank you very much. Make sure you do your homework, and I will see everyone tomorrow.